So let's just begin from the point where we exactly left in the previous class. Right. So this was a question which I gave you, that we have a set S and we wanted to determine whether this element belongs to that set, belongs to the spanning set or not. So this square bracket will be the denoting the spanning set. So there were two elements. One of them was this 2 minus 1 minus 8. One of them was 110. So one by one we have to check both the elements. So firstly we did for 2 minus 1 minus 8. So the definition of spanning set was that if the element is able to generate, if we are able to generate that element from the linear combination of the elements of S. So the set S is containing these three elements. So if we are able to find any linear combination which will generate the element, so that means it will belong to spanning set, otherwise not. So these kind of questions are always to be solved like this, that you start by assuming some constants are there, alpha 1, alpha 2, alpha 3, and then compare the coefficients, compare the coordinates, and you will always get a system of equations. So you already know how to solve the system of equations. So this will have three possibilities. It may have a unique solution. This system of equations may have a non unique solution, means infinitely many solutions, or it may have no solution. So if no solution is there, then the answer will be the element does not belong. But if you get at least one solution, either unique or infinitely many, then just list one of them, so you will be through. That means that point belongs to that spanning set. So in this case we were getting infinitely many solution, as I shown you through these calculations. So yes, this was belonging, but the other element, this I gave you to try yourself, that this element does not belong to spanning set. So I hope you might have tried, and in case anybody is having any doubt, then I'll take up at the end of the lecture, because that one more example we are going to do for the same. Okay, so let me give you another example for this only, the spanning set. So the question is still the same. Which of the polynomial? So this time we are doing for another kind of vector space. So we know that there is a vector space of polynomials. So which of the polynomial is in, okay, let's rewrite the statement. Just write, determine whether the polynomial 3x square plus x plus 5 is in x cube, x square plus 2x, x square plus 2 minus x plus 1. So basically this is given to us a set, and the square bracket denotes that we are talking about the span set, span of this set. So that means set contains four polynomials, x cube, x square plus 2x, x square plus 2 minus x plus 1, and that means we are trying to look forward whether this element belongs to the spanning of these polynomials. That means whether this polynomial can be generated by a linear combination of these polynomials or not. So it has to be done in similar way. So you suppose the 3x square plus x plus 5 is alpha times x cube, so it's the first element, beta times the second element, x square plus 2x, gamma times x square plus 2, the third element of the set, plus delta times minus x plus 1. So this notation is again your choice. You can have alpha 1, alpha 2, alpha 1, alpha 3, alpha 4, a, b, c, d, or whatever notation you can have for scalars. So I have chosen this. Now on this side, what I need to do, I need to combine the coefficients now. So what is the coefficient of x cube? It is simply alpha, because there is only one term with x cube present, so its coefficient is alpha. So now I need to combine x square terms. So this is one x square terms, this is another x square, and there is no other term with x square. So for x square, this is beta plus gamma. Then for coefficient of x, so this is x here. So you see it is multiplied with 2 and then it is beta. So it is 2 beta, and here there is no x, and here there is 1x with minus 1 and multiplied with delta. So it's minus delta into x. And finally we need to look at the constant term. So the constant term is this 2 times gamma plus 1 times delta, right? These are the two constant terms. Anywhere else there is no constant term present. So this will be the general strategy every time whenever you are doing the questions of polynomials. So you have to combine the coefficients like this, because on this side you are having another polynomial, so you want to compare one polynomial with another polynomial, and you have put a sign of equality in between. So you can only compare if you put that in this structure. So now we will be comparing, or you can say equating, the coefficients on both sides, because it's true that two polynomials are going to be equal if and only if each respective coefficient is equal. So when you compare that, so first you compare coefficient of x cube. Yes, what is coefficient of x cube on left hand side? This is 0 because there is no term with x cube on left hand side. The polynomial is a quadratic polynomial. And what is coefficient of x cube on right hand side? Alpha. So this straight away gives me one coefficient alpha. What we are trying to do, we are trying to find the value of alpha, beta, gamma and delta, that whether there exist some possible values of alpha, gamma, delta, gamma, beta, sorry, whether there exist any sort of these values which will make this linear combination true. So one value I have found, alpha is 0. Next you compare coefficient of x square. So when you compare coefficient of x square, on left hand side it is 3, on right hand side this is beta plus gamma. So this gives me one equation. Next I compare coefficient of x. So 1 is equal to 2 beta minus delta, and then I compare the coefficient of x raised to power 0, you can say, or the constant term. So 5 is equal to 2 gamma plus delta. This is a constant term. So I got these three equations. One equation is already solved, the first equation. So alpha is out of the picture, alpha is already been determined. So you have three unknowns, beta, gamma and delta, and these three equations. So now you need to solve this one and find out whether you get some values or not for this system. Yes, so if you solve this system, ultimately what you will be getting. So let me try to solve this. You again, the choice is yours. However you want to solve it, you can solve it with row reduced echelon form, or you can simply do the calculations here and try to get the value. So from first equation I get beta is equal to 3 minus gamma, and from this equation I'm getting delta is equal to 5 minus 2 gamma. So I expressed beta also in terms of gamma and delta also in terms of gamma. Now this beta and delta I'm going to substitute in second equation. So I'll get 1 is equal to 2 3 minus gamma minus delta. What is delta? 5 minus 2 gamma. So this gives me 1 is equal to 6 minus 2 gamma minus 5 plus 2 gamma. So this gets cancelled. So this get 1 is equal to 6 minus 5, which is true. True means it is trivially satisfied. So this will happen, this may happen in many of the questions, that while solving you may get these kind of equations which give you no information. This equation is simply giving me 1 is equal to 1, so which is already true. So that means you only need to look at first and third equation. The second equation, the this equation is automatically satisfied. You can do it either ways. You pick any two of them, the third one will be automatically satisfied. So this is how the system is behaving. So you get this beta in terms of gamma, delta also in terms of gamma, and since no other information is coming, we have already utilized all the equations. So that means gamma can have any value, no restriction on gamma. So actually we are having how many? Infinitely many solutions. So even if you try with the row reduced echelon form method, you will get the same answer from there. So now I just want to give one particular solution. So you choose gamma is equal to 1. You can choose any value. I am choosing gamma is equal to 1. So this will give me beta is 3 minus 1, which is 2, and delta is 5 minus 2 times gamma, which is 3, and alpha I have already determined, which is 0. So I got my one set of solutions. I was looking for values of alpha, beta, gamma, delta, and I have got at least one combination which is making that linear combination satisfied. So therefore, you will say 3x square plus x plus 5 belongs to the span of given set of polynomials, right? So only if you get a no solution here, then you have to write an answer. It does not belong to the spanning. But if you are able to get a solution, then you simply write that this is happening, this belongs there. So let me give you one more example in which you will get no solution, because uh, this example we are getting the solution. Let me just quickly take one more example for the same set. The set is same, but the polynomial which you have to check is different, right? So if this you will be put like this: alpha times x cube, beta times x square plus 2x, gamma times x square plus 2, delta times minus x plus 1. So I'll directly writing what equations you will be getting, right? You will be getting alpha is equal to 1. I'm leaving those steps, combining the coefficients and then equating the coefficients on both sides. I'm so finally writing what you will get as system of equations. Beta you will get 3 minus gamma, and one equation you will get 2 beta minus delta is 3, and one equation you will get which is going to be delta, just a minute, 2 gamma plus delta is equal to 7, right? So once you will solve these equations, so you will get no solution, because here from here you will get beta is equal to 3 minus gamma, and from here you will get you can find the value of 2, you can put the value of beta, which is 3 minus gamma. So you'll get 6 minus 2 gamma minus delta is equal to 3. So from here I will be getting delta is equal to 3 minus 2 gamma. So this value of delta, when you substitute here, so you will get 2 gamma plus 3 minus 2 gamma is equal to 7. So you get 3 is equal to 7, which is obviously not possible. So therefore the system is having no solution. So this is what will happen in these kind of cases. So that means this polynomial does not belong to the spanning set of the given set of polynomials. So these are all questions in 4 examples I have given you, in which you have to check whether a given element is a part of the spanning set or not, right? Okay, so I hope now it's clear to everybody how to determine whether a given set, or sorry, whether a given polynomial or whether a given element is lying in the spanning set or not. In some cases it will, in some cases it will not. So let me just start with the next topic from here onwards. So this is, in this we are going to learn what do you mean by linearly independent or dependent. So you already are somewhat familiar with this notation, or you can say familiar with this terminology. What do we mean by linearly independent? What do you mean by linearly dependent? So there we taught you in the very first chapter this concept in the context of differential equations solutions. Remember, when we got more than one solution and then we were checking whether these solutions are Li or our LD. If you remember, say one solution we get e raised to power x, other we get e raised to power 2x, then we used to check whether this is Li or LD. So we know how to check there by finding the Wronskian and other things. So there it was to be checked by that method. But now we are introducing the concept of LI LD for vector spaces. So actually this comes later than that, right? So because the set of solutions form a vector space, so you can say that concept is adapted one. The original context is the one which we are going to talk today. Okay, so this is the fundamental definition of being Li or being Ld, which I am going to introduce today. So let me first write the definition. A set of vectors v1, v2, vn in a vector space V is said to be linearly dependent if there exist scalars. Scalars means real numbers, right? Because we know our scalars are reals. If there exist real numbers alpha 1, alpha 2, alpha n, not all 0, such that alpha 1 into v1, alpha 2 into v2, alpha n into vn is turning out to be 0. This 0 is a 0 vector, remember, right? Because on left hand side you have v1, v2, vn. You are adding the vectors, multiplying with the scalar. So because scalar into a vector is a vector. v1 is a vector, alpha 1 into v1 is also a vector. v2 is a vector, alpha 2 into v2 is also a vector. So you're adding vectors. So on right hand side also it should be a vector. So this 0 is actually going to be a vector quantity. Now let's just look on the definition term by term. So we will be given some certain set of vectors in the vector space, and the question will be whether these are linearly dependent or linearly independent. So this is the definition, that if we are able to find, if there exist means if we are able to find some scalars alpha 1, alpha 2, alpha n such that the linear combination is becoming 0, the linear combination is becoming 0, then we say they are linearly dependent. Now the important point here is this word, not all 0. Now what do you mean by not all 0? See, let me explain you this way. What I am trying to do, I am trying to find out that whether there exists, suppose I have three vectors, suppose I have three vectors, v1, v2, v3. I am trying to know whether there exist some scalars such that their linear combination becomes 0. So you can tell me, you just multiply with 0. 0 into v1, 0 into v2, 0 into v3 is 0. So you multiply anything with 0, it has to become 0, right? So this is the trivial solution. Just like the homogeneous system of equations, that 0 solution is always there. If you want to make right hand side 0, so obviously on the left hand side you just choose your unknowns or your scalars to be 0, so it is automatically satisfied, right? So what we are saying, the trivial solution is always there. I can always multiply with 0 and create the 0 vector. What we are trying to know, that if there exist the scalars not all 0, that means at least one of these alpha i's should be non-zero. At least one of the alpha i's should be non-zero. Then we are going to say they are linearly dependent. Otherwise, otherwise we will say them linearly independent, right? So that means if there exists a non-trivial solution so that the linear combination is becoming 0, then we will say the vectors are LD. Otherwise we will say the vectors are LI. That means उनके linear combination को 0 बनाने के लिए हमें अगर zeros ही मिल रहे हैं तब तो वो Li है, बट अगर कुछ नॉन जीरो मिल रहे हैं स्केलर्स जिनसे उनका लीनियर कॉम्बिनेशन 0 बन सकता है, then that is linearly dependent. So let me just again summarize this one, how to do this in questions. So in questions we will be given the vectors v1, v2, vn. So what you do, you write the linear combination 0 and then you solve this one. Solve this one how? This I will show you in the questions. So when you solve this system of equations, this will give you system of equations. So when you solve this, So there will be two possibilities. If alpha I is 0 for all I, means alpha 1, alpha 2, alpha n. If all of them are coming out to be 0 as an answer, means that is the only answer possible, then the vectors are linearly independent. But if at least one of alpha I is non-zero, राइट एक भी उनमें से नॉन जीरो आ जाता है, बाकी सब जीरो आ जाए, कोई भी एक अल्फा आई नॉन जीरो आ जाए, देन वी विल से the vectors are linearly dependent, right? I hope the definition is clear to you, that this is how the thing is going to happen. So let's just do the questions and then it will be clear. And then I will connect with why we are checking LILD. The motivation, that why suddenly we are talking about linearly independence and dependence. So that part will come later. It has application in some certain other determination. But right now we just need to look at this one. So let me give you the question for the same. Okay. So example, determine whether the following set of vectors is Li or Ld. So I have been given this example. So I have been given the vector space, in vector space P4. P4 means, you know, this is that vector space, polynomials of degree less than equals to 4. So wherever they are given to me, so let me just do that. Okay, so the first example in this case is, this set is given to you: x square minus 1, x plus 1, x minus 1. So I have been given three polynomials and I need to know whether they are linearly dependent or independent. So how you have to start your question? You take their linear combination. So consider alpha 1 times x square minus 1, beta times x plus 1, gamma times x minus 1 is 0. Now remember, I told you this right hand side has to be 0 vector. So this one has to be a 0 polynomial. So if you will compare it with the 0 polynomial, so what is going to be 0 polynomial on this side? 0x square, 0x plus 0 into 1. So that is what the meaning of 0 polynomial. That's how 0 polynomial looks like. Why I have taken only up to x square? Because on this side the maximum power I have x square. Otherwise, if there would have been any polynomial of x cube, so I could have compared with x cube also. Ultimately, every coefficient has to be equated with 0. And this is also optional. You may not write it like this. It is just obvious you understand the meaning of it, that what is the interpretation coming from here. Now you do the calculation on the left hand side. So on left hand side, what is the coefficient of x square? Alpha 1. What is the coefficient of x? Yes. What is the coefficient of x? Beta plus gamma. And what is the constant term? The constant term is, see, minus 1 is here. So minus 1 into alpha. So this is minus alpha 1. This is another constant term. I have just confused this one. Just a minute. Let me just see one notation. Let it be alpha, beta, gamma. So there is no alpha 1. You could use alpha 1, alpha 2, alpha 3, or simply alpha, beta, gamma. So I'm using alpha, beta, gamma. Minus alpha plus beta minus gamma. That is going to be your constant term. Right. So now you compare. So you will get coefficient of x square, alpha. On this side, 0 polynomial. Now this is the question of linearly dependent independent. On right hand side, it's always going to be 0. Okay. Unlike the spanning set. In spanning set, on one side you have something vector which is given to you, but in linearly independent dependent questions, that is always 0. So alpha is 0, beta plus gamma is 0, minus alpha plus beta minus gamma is 0. So tell me the solution of this system. You have three equations, three unknowns. Alpha is already solved. You put this value is here. So this will give me beta minus gamma is 0. So I'm left with these two equations. Beta plus gamma is 0, beta minus gamma is 0. Yes, what are the values of beta and gamma? 0, 0. It's very easy to solve. Beta is 0, gamma is 0. So this is my final answer. Now what is this? This is the zero solution, or we say the trivial solution. See, name does not matter whether you call it trivial solution or not. What matters is you should look at their values. If all of them are 0, so what should I write? They are, the set is linearly independent, Li, because the scalars are turning out to be 0. So this is one example. Let's just quickly do other example. In this, all scalars are coming 0. There were 3 scalars, so the set is Li. So let's just do the second example. So in this case, the set which is given to me is this: x square minus 4, x plus 2, x minus 2, x square by 3. So let's take the linear combination: alpha 1 times x square minus 4, alpha 2 times x plus 2, alpha 3 times x minus 2, alpha 4 times x square by 3 is equal to 0. So you don't need to write every time 0 vector, but you know it is a vector. So let's compare the coefficient. So the largest possible degree is x square. So the coefficient of x square will be this: alpha 1 plus alpha 4 by 3. Coefficient of x will be, these are the only two terms where I can see x. So alpha 2 plus alpha 3 into x, and then the constant term will be minus 4 alpha 1 plus 2 alpha 2 minus 2 alpha 3, which is equals to 0. So now each of these individually should be equals to 0. So this gives me alpha 1 plus alpha by, alpha 4 by 3 is equal to 0. Alpha 2 plus alpha 3 is 0. Minus 4 alpha 1 plus 2 alpha 2 minus 2 alpha 3 is 0. So basically I have 4 unknowns, but I have 3 equations. So you may get any kind of system, rectangular or square. So let's try to figure out what is the possible solution from there. So first equation I get alpha 1 is in terms of minus alpha 4 by 3. From second equation I get alpha 2 in terms of alpha 3. So you see alpha 2 has been obtained in alpha 1 has been obtained in terms of alpha 4. Okay, just substitute both of these in this equation. So minus 4 times minus alpha 4 by 3 plus 2 times minus alpha 3 minus 2 alpha 3 is equal to 0. So this will give me 4 alpha 4 plus 12 alpha 3 is equal to 0. So alpha 3 is minus 1 by 3 times alpha 4. So howsoever you solve this equation, this way of solution is not unique. As I've told you many times, you are free to choose which variable you want to express in which variable. So I got alpha 1 also in terms of alpha 4, alpha 3 in terms of alpha 4, and from here alpha 2 is also in terms of alpha 4. And so alpha 4 is free variable, right? Alpha 4 is arbitrary, can have any value. So therefore I can have alpha 1, alpha 2, alpha 3 in terms of alpha 4. And how many solutions you are getting from here? So okay, the point is we need not tell how many solutions are getting. We just need to know whether there exists a non-zero solution or not, right? Whether there exists a non-zero solution or not. So yes, there exists a non-zero solution, because if I choose alpha 4 is equal to 1, so I can get alpha 1 is minus 1 by 3, alpha 2 is 1 by 3, and alpha 3 is minus 1 by 3. Yeah, so this is the answer. You can just check the calculation. So these are our non-zero scalars. So you are able to get non-zero scalars. So therefore the given set is linearly dependent. So you see, basically in all the questions we are doing similar sort of things. Everything just leads down to solve a system of equations. So you should be very efficient in that. Okay, Gurtej, you are asking if we choose alpha 4 is equal to 0, then obviously all the alphas are 0. But remember, just try to see what I said. I said here, if there exists the zero solution, that means zero solution is the only solution. If alpha is 0 for all I means this is the only unique solution possible. दैट मीन्स नॉन जीरो कॉम्बिनेशन एग्जिस्ट ही नहीं कर रहा है जो उन वेक्टर्स के कॉम्बिनेशन को जीरो बना देगा, ऐसे नॉन जीरो स्केलर्स है ही नहीं, तब हम उसको लीनियरली इंडिपेंडेंट बोलेंगे. बट अब अभी वाले क्वेश्चन में अब आपके पास यहाँ पे जीरो सॉल्यूशन तो है ही है, जीरो चॉइस तो हमेशा रहेगा ही रहेगा. आपको देखना है कि क्या नॉन जीरो वैल्यूज हैं ऐसी जो उसको जीरो बना सकती हैं. तो इफ यू आर एबल टू फाइंड एटलीस्ट वन नॉन जीरो सॉल्यूशन, सो दे आर लीनियरली डिपेंडेंट. Right? I just hope that is clear. Vidushi, I said one should be non-zero. At least one should be non-zero. I did not say at least one should be zero. Maybe I wrote, let me check. Yeah, you just read that again. For linear dependence, at least one of them is non-zero means uh, all of them can also be non-zero, but one of them has to be non-zero. Right? So this is how you determine linearly independent and dependent. I have done 2 questions so far, but we will do more questions of linearly independent and dependent because the same concept is going to be introduced for the next concept also, the next definition. Right? Yes, Uday, there are infinitely many solutions. Again, the point is we just need to know whether there exists one non-zero solution or not. At least one, at least word is there. So there can be more than one also. There can be unique non-zero solution also. There are all the possibilities. You just focus on if the only solution is zero solution, then Li. But if there exists at least one non-zero solution, then LD. As simple as that. Okay, so let me just move ahead in this. So now you have done two concepts, spanning and checking LILD. So now we will combine that into a single definition, which is basis. Actually, for every vector space there exists a basis set. Now let me give you the definition of that basis set. That a non-empty subset. So first of all, obviously, it cannot be an empty set. A non-empty subset B of a vector space B is said to be a basis of vector space V. So it's going to be a basis set, right? So it's a set basically, but it's just having a particular name, basis. So we will call a particular subset as a basis if, so there are conditions, two conditions which need to be satisfied. The first condition is B is Li, means linearly independent, and the second condition is B spans V, that is V is the spanning set of V. So that means if you find the spanning set of V, you should be able to generate the whole vector space. Now, if you recall the definition of spanning set, if you recall the definition of the span, I told you that span means that if the elements can be generated from the linear combination. So whatever be the number of elements in B, if by the linear combination we can generate every element of V, right? So then we will call that set as a basis set. So that is every element of vector space can be written as a linear combination of elements of B, then means this is the meaning of the second condition. Every element of vector space if can be written as a linear combination of elements of B. So this is one condition, and the other condition is it should be linearly independent. So if any particular set is satisfying these two conditions, then we will call that set a basis set. Right? Is the definition clear? Is there any doubt in the definition? We will come to the questions and even elaborate this more, but for the time being, I'm just asking if there is any doubt in the definition or anything. Yes, Yuvraj.
Ma'am, does it mean that ma'am B will only have a trivial solution?
Yeah, B is Li. So now we know two separate things. Being Li, what does it mean? We just seen in the question, and being spanning, what does it mean? That we have seen. So there are two different things. So if B will satisfy both the conditions, then we will say that as a basis set. We do not use this term B is having only trivial solution. The linear combination of B becoming zero is having trivial solution. That's how precisely you should say it. Is it clear? Am I clear on this? Yeah, right. Okay, let's just move ahead towards the question, and then you will be more clear about what is this second condition. Because if you remember spanning, for spanning I told you that suppose आपके पास तीन elements हैं, right? तीन vectors हैं, alpha 1, alpha 2, alpha 3, और आपके पास किस तरह के question आते हैं कि आपको एक particular element दे देंगे, say 101, और पूछेंगे whether it belongs to it's spanning or not. The kind of questions we have done today as well as in the previous lecture. So we know that how to do that, कि हम assume कर लेंगे कि yes वो spanning में है, और फिर देख लेंगे अगर तो अल्फा बीटा गामा की वैल्यूज आ गई एक कुछ भी जिससे वो पॉसिबल हो सकता है कॉम्बिनेशन, फिर बोलेंगे बिलोंग करता है स्पैनिंग में, अदरवाइज नहीं. तो आपको इंडिविजुअल एलिमेंट तो चेक करना आता है, बट यहाँ पे हम कह रहे हैं एवरी एलिमेंट ऑफ वी. अब वेक्टर स्पेसेस में इनफाइनेटली मेनी एलिमेंट्स होते हैं. आपका वेक्टर स्पेस क्या है? V3 है, R3, three-dimensional real space. So it has infinitely many elements. Or your vector space is like containing of polynomials. So there are infinitely many polynomials. So theoretically it is impractical कि हम इस condition को check करें, कि हर एलिमेंट को चेक करना तो पॉसिबल नहीं है. सो देर विल बी अ वे आउट विच आई विल टेल यू हाउ टू डू दैट इन क्वेश्चन. बट राइट नाउ लेट्स जस्ट फर्स्ट डू द वेरी फर्स्ट एग्जाम्पल and then see how to simplify the second condition. So let's do the very first example of this basis element. So you are given this set B 1 0 0 0 1 0 001. So I will show you that this is a basis of V3, means the three-dimensional real space. So I want to show this, that it is a basis. So for that I will show first this is a linearly independent set, and then I will show the spanning. So first part is Li. So to show that B is Li, अब Li कैसे शो करना है ये अभी हमने किया था. आई जस्ट शोन यू इन दिस. यहाँ पे पॉलिनोमियल्स थे, ये जो एग्जांपल मैंने दोनों लिए ये पॉलिनोमियल्स के थे. अब हम एक डिफरेंट वेक्टर स्पेस में हैं तो वहां पे डिफरेंट एलिमेंट्स हैं, बट डेफिनेशन वही रहेगी. Li की डेफिनेशन क्या है? आपको लीनियर कॉम्बिनेशन कंस्ट्रक्ट करना है, उसको जीरो के इक्वल रखना है, और फिर देखना है कि उसके क्या सोल्यूशन आते हैं. उसके बेस पे हम डिसाइड करेंगे Li और Ld. सो लेट्स जस्ट डू दैट. सो यू कंसिडर अल्फा टाइम्स फर्स्ट वेक्टर, बीटा टाइम्स सेकंड, जो भी आपको सेट में गिवन है जिसको आप बेसिस चेक कर रहे हो उस सेट के आपने एलिमेंट्स लेने हैं, एंड गामा टाइम्स द थर्ड. दिस शुड बी इक्वल टू जीरो. नाउ जीरो वेक्टर, अब ये कौन सी स्पेस में हो आप? R3 में. सो जीरो वेक्टर इज दिस नंबर, दिस वेक्टर 0 0 0. right? So on left hand side, what is the vector on left hand side? So this is alpha 0 0 0 beta 0 0 0 gamma 0 0 0. So on adding, अब add कर सकते हो आप इनको, you will get alpha beta gamma 0 0 0. This will give me alpha 0 beta 0 gamma 0. So firstly we'll just do the keep doing the calculations on the one side. जैसे पॉलिनोमियल्स में कैलकुलेशन करने का तरीका है कि हम कोएफिशिएंट्स इकट्ठे करना शुरू कर देते हैं, एक्स क्यूब के एक साथ एक्स स्क्वायर के, और फिर इंडिविजुअली सबको जीरो के इक्वेट करते हैं. जो इस तरह के वेक्टर्स होंगे टपल्स वाले, उनमें हम coordinate wise separate करते हैं calculation, first coordinate, second coordinate, third coordinate. So what I did, I multiplied with the scalars on left hand side and then just did this calculation. So then once I am sorted on this side, then I will compare it with the right hand side. So put each of them equal to 0. So here very conveniently directly I am getting the answer. I'm not getting a system of equations, I'm directly getting the solution only. Yes. So is there any other possibility? There is no other solution. So this is the only possible solution which will make this star satisfy. Only possible solution to this star. This implies yes, this set of vectors B is linearly independent. अब दो terminology है, आप ये भी कह सकते हो the vectors in the set B are linearly independent, आप ये भी बोल सकते हो the set is linearly independent. वो एक ही बात है. सेट का लीनियरली इंडिपेंडेंट होना मींस उसमें जितने भी एलिमेंट्स हैं वो लीनियरली इंडिपेंडेंट है. सो एलआई तो हमने प्रूव कर दिया. अब हमें चेक करनी सेकंड कंडीशन. व्हाट इज द सेकंड कंडीशन? कि बी जो है वो पूरे वेक्टर स्पेस को स्पैन करेगा. दैट मींस वेक्टर स्पेस का हर एलिमेंट शुड बी रिटन एज अ लीनियर कॉम्बिनेशन ऑफ द एलिमेंट्स ऑफ बी. सो बी शुड स्पैन द होल वेक्टर स्पेस. अब हमारा होल वेक्टर स्पेस है R3. अब R3 में स्ट्रक्चर क्या है एलिमेंट्स का? मींस R3 अगर मुझे बोलना हो कि डिफाइन R3, so you will give me this definition. This is how the elements of R3 looks like. 3 tuples, right? X, Y, Z. X, Y, Z belongs to R. So what I should show that X, Y, Z should be able to, I should be write any general element. I am not picking any particular element. I need to show any element, means any general element should be able to write as a linear combination of the elements of B. So it should be alpha times 1, 0, 0, beta times 0, 1, 0, plus gamma times 0, 0, 1. This is what the meaning of span. So I should be getting some values of alpha, beta, gamma. अब ये वाले क्वेश्चंस और जो हमने पहले किए हैं स्पैनिंग सेट के क्वेश्चंस, उनमें यही डिफरेंस है कि वहां पे एक पर्टिकुलर एलिमेंट गिवन होता था आपको, जैसे उसकी न्यूमेरिकल वैल्यू होगी. यहाँ पे ये एक जनरल एलिमेंट है क्योंकि आपको इनफाइनाइटली मेनी एलिमेंट्स को शो करना है. सो आप एक जनरल एलिमेंट से स्टार्ट करोगे, राइट? सेम कैलकुलेशन. Okay, what I'll get on this side is alpha, beta, gamma. All of you can see this is the same linear combination, and on this side I have x, y, z. So clearly alpha is x, beta is y, gamma is z. So I am getting some alpha, beta, gamma where I can write this. So clearly x, y, z can be written like x time 1, 0, 0, y time 0, 1, 0, z times 0, 0, 1. Since I am able to write it like this, therefore every element of R3 can be expressed as linear combination of elements of B. ये B से लिए थे मैंने जो 3 वेक्टर्स लिए थे. So this implies B spans V3. It implies B is basis of V3 क्योंकि Li भी प्रूव हो गया है और स्पैनिंग भी प्रूव हो गया है. So it's very easy to check the second condition इस particular question में. It's something like अगर मुझे वेक्टर लिखना हो 2, 1, 3, so I can write it like 2 times 1, 0, 0, 1 times 0, 1, 0 and 3 times 0, 0, 1. So जो भी वेक्टर दोगे I will be able to write this. तो जो यहाँ पे एलिमेंट्स होंगे वही स्केलर्स यूज हो जाएंगे बिकॉज अंदर 1, 1, 1 है. ओके, सिमिलरली you give me any other number, say -4, 5, 0. So I should be able to write it like -4 times 1, 0, 0 plus 5 times 0, 1, 0 plus 0 times 0, 0, 1. So I'm able to do that. So this is what exactly I have shown it for a general element, that this is happening. Therefore, this is the basis. Okay, so that's all about today. We'll do more examples tomorrow. Meanwhile, in this 1-2 minutes, you can ask me if you have any doubts. यस उदय।
मैम रेड बॉक्स में मैम क्या बता रहे थे, हमें वो बता दो।
ये रेड बॉक्स में मैंने ये बताया है कि ये जो हमने शो किया है एक्स वाई जेड, क्योंकि हम जनरल शो कर रहे हैं किसी भी एलिमेंट्स के लिए। यू सी क्या आया, कोई भी एलिमेंट होगा एक्स वाई जेड, उसको मैं ऐसे लिख सकती हूँ एक्स टाइम्स 100 वाई टाइम्स 010 प्लस जेड टाइम्स 001। आप करके देख लो सॉल्व, इस तरफ यही आएगा ना, एक्स टाइम 1 वाई टाइम्स 1 जेड टाइम्स 1। तो जब ऐड करेंगे यही वाला एलिमेंट जनरेट हो जाएगा, राइट। तो ये हमने प्रूव करना था और हमने प्रूव कर दिया। ये मैंने इसका एग्जाम्पल दिया है, इट्स ऑप्शनल, मीन्स आपको जब जनरली प्रूव कर दिया फिर आपको एग्जाम्पल देने की जरूरत नहीं है। ये मैंने आपको इसको समझाने के लिए कि इसका मतलब क्या है कि कोई भी वेक्टर आप मुझे रियल स्पेस में से दोगे, 3 डायमेंशनल स्पेस में से, मैं इन तीनों के लीनियर कॉम्बिनेशन में आई कैन ऑलवेज एक्सप्रेस, यू कैन गिव मी एनी वेक्टर। सो मैंने 2 एग्जाम्पल लेके आपको दिखाए थे।
ओके मैम। एंड मैम मैम एक वेक्टर स्पेस का मैम यूनिक बेसिस होगा या मैम एक
नहीं।
साथ हो सकते हैं?
नो, वो विल कम टू दैट टुमारो। अभी सिर्फ क्योंकि एक ही एग्जांपल किया है हमने, तो ये वाला एक सेट तो मतलब हमें पता चल गया कि देखो ये R3 का हमारा बेसिस सेट है, बट वी विल डू मोर एग्जांपल्स। उससे आपको पता चलेगा कि ये यूनिक नहीं होता है, एक से ज्यादा बेसिस भी एग्जिस्ट कर सकते हैं।
ओके मैम, थैंक यू।
राइट, ओके, यस ईशान।
मैम सेकेंड एग्जाम्पल में जो सेकेंड पार्ट है उसमें कब स्पैन नहीं करेगा, जैसे हमने देख लिया कि अल्फा एक्स है, बीटा वाई है, गामा जेड है, तो अगर इसमें से कौन से वैल्यू तब आएगी जब स्पैन नहीं करेगा?
मीन इस क्वेश्चन में तो स्पैनिंग है, ये तो समझ आ गया ना आपको।
हाँ ये समझ आ गया, बट क्या कंडीशन होगी कि स्पैमिंग नहीं होगी? उस केस में
हाँ,
क्या होगा, अल्फा नॉट इक्वल टू एक्स?
नहीं नहीं नहीं, आपको हम क्या कर रहे हैं, हम स्पैनिंग फाइंड करने के लिए ये कर रहे हैं कि क्या कोई अल्फा बीटा गामा एग्जिस्ट करते हैं सो दैट ये एलिमेंट जनरेट हो जाए। तो ऑब्वियसली अगर ये एक्स वाई जेड न्यूमेरिकल वैल्यू होती जैसे ये होता, तब सब लोग सॉल्व कर सकते हैं जैसे हमने पहले किए। बट यहाँ पे ये आए अल्फा बीटा गामा एक्स और वाई जेड की टर्म्स में आ गए। मैं ये नहीं कह रही इक्वल आने चाहिए, द ओनली थिंग इज वी आर लुकिंग फॉर अल्फा बीटा गामा कि क्या ऐसे अल्फा बीटा गामा है इन टर्म्स ऑफ एक्स वाई जेड जो इसको पॉसिबल बना देंगे। तो वो हमारे पास हो गया था। आई विल जस्ट गिव यू, आई विल नॉट गिव यू एग्जाम्पल, वी आर डन विद टाइम। अब मैं कल दूंगी इसका एग्जाम्पल कि कब स्पैनिंग नहीं होगा, राइट। जस्ट रिमाइंड मी टुमारो इन द बिगिनिंग ऑफ द लेक्चर, ओके।
मतलब फॉर्म कोई भी कर सकते हैं, जैसे अल्फा इक्वल टू एक्स प्लस 1 आता तो
हाँ
हम
हाँ
उसको
हाँ,
एक्स
हो
प्लस 1
सकता है,
लिख देते हैं।
एक्सेप्टेबल एक्सेप्टेबल।
ओके ऑलराइट।
Okay, will tomorrow continue? Yeah, thank you.